Hey, algebra students, I wanted to do particular examples with you just to show you how one formula can be used to find different variables, okay? So let's take a look at the first one. It says hummingbirds can fly at a rate of 15 meters per second. Guys, I love hummingbirds. They're so cool. I grew up in Hawaii where there aren't any. And now I live in Arizona. I have so many in my backyard. They're so neat. But anyway, they dart around, don't they? 15 meters per second. In a 30-second flight across the garden, how far could a hummingbird fly? Now, realize it or not, this particular problem has a formula on the formula sheet. There is what's called the distance formula. So look past all those geometry formulas at the top and get down here to almost the very bottom. It's the second to the last formula we want down there, the distance formula, and it says D is equal to RT. I would print out a paper copy of the GED formula sheet, guys, and just kind of mark on it. No, you won't be able to take your own copy in when you go to take the test, but having these kind of markings on there as you study could really help you out. So when I say D equals RT, that D, it stands for distance. The R stands for rate. So like how fast you're traveling. Like think miles per hour or meters per second, things like that. A rate is some number of distance per time. So meters per second, miles per hour. And then the T does stand for time. Okay, get that on your formula sheet so that you know what those variables stand for. And then let's hit up that problem. All right, so we said D equals RT, where distance is D, rate is R, and T is time. So what do we know here? Well, I see this 15 meters per second. Now it does tell us that that's the rate. That was kind of them, but they didn't have to say that. Just the fact that it's meters per second tells me that that's the R, that's the rate. And so I'll put in a 15. I'll substitute a 15 for the R. And then take a look at this. This is a 30-second flight. Now be careful. Make sure that the time in your actual time matches the time in the rate. That's one of the tricks. Like they could give you per hour and then ask you about minutes, or they could give you per seconds and ask you about minutes. But they were kind to us this time. It's per second and they gave us seconds. And so no tricks to this particular problem. I'm just going to replace T with 30. Notice that I put it in parentheses because that R and that T are shoved together. They are multiplying. And now D is the thing we don't know, right? It says how far could a hummingbird fly? So unknowns remain letters, equal signs stay steady. And this is a simple little problem because these two numbers are on the same side of the equal sign. I'm just going to go ahead and do that math. 15 times 30 tells me that little hummingbird in 30 seconds could go 450 what? This was meters per second, so that'll be meters. Woo, zippy bird. Okay, now let's look at the next example because this is the one students usually get wrong. It says the train traveled 600 miles in 12 hours. What was the train's average rate of speed? So a lot of students will bust out the D equals RT formula, but then they'll make a really bad error here. They'll just automatically assume that everything always goes on the right. And they'll put in the 600 and the 12 over there on the right, and then they'll tell me something nuts town, just craziness. They'll tell me that this train was going 7,200 miles per hour. Wow, guys, it's a fast train, faster than a plane. Something has gone wrong if our train is going that fast. Now, what went wrong? It was our algebra. It was that we forgot that we can use these formulas to solve for any of the variables, but you have to pay attention to what you have. So let's start here. 600 miles. Is 600 miles a rate or a time? No, it's not. It's not the speed. It's not how long. Guys, 600 miles is the distance, which means 600 miles has to replace D in this particular formula. And so I will replace my D with a 600. Now my equal sign will stay steady. Okay. Next thing, let's see, the R. R is the rate of speed. And notice what this says. It says, what was the train's rate of speed? R is the thing I don't know. It's going to remain R. Now, I do know the time, though. Take a look. The time, 12 hours. And so that's a 12 here. Now, what are this R and this 12 doing here? If they're shoved together like this, they're multiplying. Now, this might look really funny to you, and it might be freaking you out. And if it does, let's just take the time to rewrite this the way a mathematician would write it. Remember that when we talk about multiplying numbers and letters, we write the number, also called the coefficient, first, and the letter second. And then once the equation looks like this, students are usually clear with what to do. Oh, that 12 and that R are multiplying there. I want to solve for R. R is not alone, so I'm going to use opposites. I'll divide away the 12. Now, I'm making a change, not what they told me to do. This problem originally said 12 times R, and I'm not going to times. I'm doing the opposite, so I'm going to do it to both sides, right? I can do whatever I want as long as I keep my balance. So multiplying and dividing by 12 are opposites. They cancel. R is alone, just like I wanted, and there's the math to do. 600 not times 12, but divided by 12. And I get 50, and that makes more sense, you guys, okay? 50 miles per hour for a train to travel rather than, 7,200 miles per hour. And you might say, Kate, how do you know it's miles per hour? Well, remember, this 600 was miles, and this 12 was hours. And even look at this, miles per hour. Paying attention to what divided can help us to see that rate. That's 50 miles per hour. If the unit part just went over your head, good news. You wouldn't have to know probably that was miles per hour for the GED, but you would have to know it's not meters per second because I didn't have meters and I didn't have seconds. Let's look at the next example. Lucy drives at an average rate of 65 miles per hour. Well, that was nice that they told me that was a rate, but I knew that was a rate because look at that language, miles per hour. If she has to travel 338 miles, 338 miles, what is that? That's distance. To get to her grandmother's house, how long will the trip take? They're asking me, how long will the trip take? They're asking me about time. Time's the thing I don't know. So let's bust out our formula, our distance formula. D is equal to RT. And we know the distance. The distance was 338 miles. Okay? And that's going to be equal to, we know the rate. The rate was 65 miles an hour. And we don't know the time. And I could put that T in parentheses, but I don't need to because that's the way we usually write it when we're multiplying numbers and letters. We write the coefficient or the number first and the variable or the letter second. And now I can see that I don't know what T is right now because T is not alone. It's time to start solving. I will do the opposite here. I will divide away that 65. And I can do whatever I want as long as I do the exact same operation with the exact same number to the other side. And let's see, on the right-hand side, multiplying and dividing by 65 are opposites. They'll cancel. T is alone like I wanted. And on the left-hand side, there's the math to do. 338 divided by 65 gives me 5.2. So how long is it going to take Lucy to get to her grandma's house? Well, remember, we're looking at time. So that's 5.2. Let's see, what was I in? Miles per hour. So that's 5.2 hours. All right. Beautiful. Tricky, tricky. What I want you to walk away with, guys, is that I have a formula with D, R, and T in it. That means that I can use that formula to solve for any of those three things. It can be used straightforward to find the distance, but it can also be used using our algebra skills to find the rate or the time. Strong work.